Okay, guys. So in this lecture, we'll be talking about the performance of the objects. Okay, if we use the objects, like what is the benefit of using objects, and like what are the performance in terms of Pigo. Okay, so let's start with this. Okay, so why we should use objects? So let's say the order of the data doesn't matter. Let's say you don't want to use. Let's say you don't want to use the data, you don't want to store the data in sequence. Okay, so in that case order can be one of the best option for you guys. Okay, because the insertion and removal or accessing of data is way faster in objects, right? In comparison to arrays. Okay, so we will see some of the big O's of it. Let me quickly zoom it a little bit so you guys can see. So insertion in the objects is O of 1 like constant time, and then removal is also O of 1 constant time. Since the order doesn't matter, we don't have to worry about the sequence, right? We'll simply access the key and we can remove that particular data which is stored in the key, right? We simply go to that key directly and then we either we add it into the object or we remove it. So there is no starting and no ending in an object, right? We can add as much as data we want, we can remove as much as data we want without touching the other keys which are already stored in the object, right? So searching is big O of, it should be big O of n. Okay, why it is big O of n, that I'll get into in a minute. Okay, and accessing the data, accessing the values are constant time again. So let's create an object quickly. Okay, let's create an user. Okay, and let's say he have name Raunak. It should be Raunak. Okay, and then let's say he have age, let's say 25. Okay, and is male. Let's pass as true. Okay, so right now we have three keys. So let's go one by one. Let's say I want to insert one more key, then I can directly go ahead and insert one key, right? It's not gonna affect any of these keys, right? If I want to remove any key, then I'll simply use this key and I can use delete keyword to directly delete that key, and it is again not gonna affect any of the other keys which exist in the object. Okay, so that is why I was saying like insertion and removal is constant time, right? Doesn't matter like how big your object is or how small your object is, it's always gonna be constant time. Insertion and removal. Searching, now let's say you want to search something which is on the left side in the object, right? I'm not talking about the keys which is which is on the right side of the object, right? I'm not talking about the things which are in the left side. Okay, so in this side if you are searching something, that can be a little tricky. Okay, so let's say in an object you want to search which key stores the value Raunak. So in that case what you will do, like you will collect all the keys and then you will search like does this key have the text Raunak? No. Does this key have the text Raunak? No. Does this key have the text Raunak? No. Okay, so in case if you find any place where like that particular key have that text Raunak, okay, then you will check what is the key, what is the name of that key. Okay, so it can be O of n, right? Because this way we have to check one by one all the values, and then if the value matches with the one which we are looking for, then we will check the keys. Okay, so this way it can grow up to n, right? So because it doesn't have any end, right, it can goes up to n. So that is why searching of a value directly can be tricky. So that is why we have O of n. Time complexity of this one will be O of n. Okay, if you are searching something directly on the right side. Okay, yeah. So now accessing the keys, again it will be constant time only, because Let's say you want to search the age, then what you will do, user.age, directly you are accessing it using its keyword. Again, it's constant time, it doesn't matter like how big or how small your object is. Okay, so it will directly take you to the value of that particular key. Okay, it is same as like accessing the second key, as like you are accessing the 1000 key. Okay, the time will be same, it's gonna execute the result in the same amount of time. Okay, now let's talk about big O of some of the methods which are available in the objects. Okay, so in objects we have keys, right? And as you can see, keys, values and entries are O of n, which sort of makes sense. Why? Because let me show you quickly, right? So user, let's object dot keys, let me quickly zoom it in. Okay, so here I'll pass the object which I already have, user. Okay, so as you can see, I'm getting 3 keys here, right? So it is directly proportionate to the amount of data which we have stored in the object. So let's say we have 1000 properties in it. Okay, so it's gonna show us the 1000 keys, right? So that is why it is directly proportionate to the size, right? So the size of object grows, the amount of time which it takes to execute the result will also grow. Okay, so that is why like we had the time complexity, the big O of object.keys is O of n. Okay, because because we don't know like how much this object can grow, right? And the amount of keys which we have in the object is gonna show us that key, so this array will grow gradually. Okay, and same is with the values. Let's just enter it to get the result. Now if I use values, again same thing will happen. Okay, it's not value, it's values. Apologize, I missed it. Yeah, so in values also, as you can see, it is just giving the values of all the properties, right? And it is also directly proportionate to the size of the object, and the size of object does matter here. If the size of object increases, the amount of time which it takes to execute the result will also increase, right? So same way we have object dot entries, which is also doing the same work but a little bit more work. Let me show you. Okay, this one, right? So what it is doing, like it is wrapping the key and value in the array, in the sub array we can say, and then it is storing them in the array, right, in the sequence. So that's that in that way it have a little bit more work, but end of the day it is also simplified to the big O of n, right? Because it is also going to take the same amount of time as the object dot values or entries take. Okay, so the object dot entries is also going to be big O of n. Okay, the big O of object dot entries. Now if you talk about the has on property, so it's gonna take big O of one, right? Which sort of makes sense because here we have to pass the property name directly, right? It doesn't have to worry about the size of the object is whether big or small. It's just gonna check that property directly into the object and it's gonna give us the result, whether it is there or not. Okay, it doesn't care about the size at all of the object. Okay, so user dot has on property, let's pass name, right? So instead of property name, see the property name, this key itself is not there, that's why it is giving us false. Okay, so let's try the property which exists, name, it exists here, so it gave us true right away. Okay, so what it will do, it will directly check that property into the object. So in simple words, we are directly accessing that property, right? So it's not gonna take much time. Okay, so that is why like the big O of has on property is also constant time. Okay, so it doesn't have to worry about the size at all. Okay, so yeah, this is what like the performance wise, or we can say through the lens of big O, the object is. So in next video we are going to see the arrays, because arrays is going to be a little bit more interesting, because there we store the data in sequence, right? And I'll show you like what will happen if you add some data in the beginning of the array, and what will happen like if we add some data in the end of the array. Okay, so this is it for this lecture, guys. See you in the next one.